Right. Does this still work? Does it still work? Let's see. Seems to work. Let's see. Seems to work. Okay. Anyway, long time since I've been streaming. But yeah, I don't know. It's not a. I wanted to do today to work on the. Found this blog post. Write your own virtual machine. And apparently there is a thing called LC3. That stands for Little Computer Tree. Which is like I don't know, an educational virtual machine. Protocol, architecture, educational programming language, assembly language. Anyhow, this. And yeah, I thought it would be nice to do, and I'm like, yeah, sure, might as well stream it. So yeah, that's where I am now. Hello! Hey, what's up? What's up? Let's write a virtual machine. Seems simple enough. Yeah, okay, they don't have any examples on Wikipedia, but this guy does, so should be easy enough to do. And I'm gonna write this in Rust, because that's the language I use for work now, and might as well gain some experience. It's quite enjoyable. In this tutorial, I will teach you how to write your own virtual machine that can run assembly language programs such as my friend's 2048 and my roguelike. If you know how to program, okay, deeper understanding, write your own VM. I'm sure it's fine. He's about to code it in C or C++, but yeah, that doesn't matter that much. What is a virtual machine? I think I know already. It's like fake machine instructions, but like the virtual machine for like a programming language. Virtual machine is like the virtual machine itself is compiled for different architecture, but then your code can just run on the virtual machine, which sounds a bit strange, but I guess it was an issue a long time ago. But anyway, sounds fun to do anyway, so let's do it. What is a virtual machine? A VM is a program that acts like a computer. It simulates a CPU along with a few other hardware components, allows it to perform arithmetic. Oh, maybe it's not that. Okay, it's not for a specific language like Java or Python. I don't know if you can call the Python interpreter a VM, because it does produce some kind of bytecode, but okay, maybe I'm confusing the concepts a little. Read and write to memory, interact with I/O device, just like a physical computer. Most importantly, it can understand. You're thinking about the GVM, right? Yeah. It's a bytecode VM. Okay, so like the programming language kind of thing is a bytecode VM, and this is like a VM, but like educational. Okay, maybe I don't know what the fuck I'm talking about, but anyway. Most importantly, it can understand a machine language, which you can use to program it. The amount of computer hardware the VM attempts to simulate depends on its purpose. Some VMs are designed to reproduce the behavior of some particular computer. Ah, yeah, okay. So the video game simulator could be considered VMs, of course. VM is a program that can run a different operating system, for example. Yeah, I know, but like sometimes they call it. What's the difference? You just call it a bytecode VM because they still call it a VM, you know. So and like I doubt that the Java virtual machine is like an entire operating system, or the Python bytecodes thing is an entire operating system. Yeah, I don't know. I think the naming is just a bit confusing, but we all know like what those things are. Uh, Other VMs don't act like any real computer and are entirely made up. This is primarily done to make software development easier. Imagine you wanted to. Yeah, true, it's a bit confusing. Yep. Imagine you wanted to create a program that ran on multiple computer architectures, a VM. Yeah, okay, that's basically what Java does, kinda. You would only need to write a small VM program in each assembly language. Each program would then run on the VM assembly language. Okay, porting with... I think that got kind of solved with LLVM. Like, now people just write code for that compiles to the LLVM, I don't know what it's called, the LLVM language. And then LLVM takes care of the heavy lifting of compiling that for all kinds of different architectures. So yeah. Also, I look very orange on the camera. Maybe I will just set the light. Alright. Yes, feel like a real streamer now. Taking care of the lights. Porting without a VM, porting with a VM. Generating LLVM is harder than writing a VM. SG... Well, I don't know that acronym at the end, but yeah. Yeah, it's true, but it feels like everybody is now doing the LLVM stuff. Well, no, everybody does the LLVM stuff, and then they go back to have a self-hosted compiler. Like, that's what Zig did, I think. I don't know, I think Odin uses LLVM? I don't fucking know. Anyway, there was a meme like by Tsoding, like, stop using LLVM wrappers or something. Anyway. Higher intermediate representation. Ah, yeah. Yeah, that's what it's called. No, the compiler solves a similar problem by compiling. Yeah. Anyway, I just want to get into the coding, my dude, please. Yes. VM is awesome, VM is awesome. LC3 architecture. Our VM will simulate the LC3 educational computer architecture commonly used to teach university students computer architecture and assembly. It has simplified instructions set compared to x86. Yeah, I don't want to read that. Wait, that's x86? Looks like it. It's way too long. Okay. But oh wait, that's a nice bookmark. Because I'm always struggling to find some page where all the x86 architectures, like instructions, are written. It's really nice. And it details like up 1, up 2, up 3. Okay, yeah. Save it for later. The word VM is definitely overloaded. Yeah, it's like kind of AI or well, yeah, AI means a bit everything and nothing. I'm thinking a bit about crypto, but crypto is not really overloaded. It's just hype, I guess. AI is both overloaded and hype. So yeah, I don't know. OVMA, yes, but demonstrate the main ideas used by modern CPUs. No, the LC3 is defined in Introduction to Computing System. This is, yes, some book. To start, we need to simulate the essential hardware components of the machine, try to understand what each component is, but don't worry right now if you're unsure how it fits in the larger picture. Start by creating a C file. Each of the code snippets in this section should be placed in the global scope of this file. Ah yeah, we're gonna have globals. Yeah, Rust is gonna love that. That's gonna be awesome. The LC3 has this amount of memory, so basically the max int 16, I think. Location, the maximum that is addressable by a 16-bit integer, unsigned integer, each of which stores a 16-bit value. This means it can store a total of only 128 kilobytes, which is a lot smaller than you may used to, but it's probably fine. Okay, so what I'm gonna use is a trick, so you can do cargo add static cell, like so, and this is gonna make my life much easier, I think, because I can just make use static cell, and I can just have a static memory that is gonna be static cell. Hello Charles, how are you? I'm good, thank you. A static cell of U16, which is gonna be an array of U16, he said like, well, it's U16 max, this, like so, and this is equal to static cell new, like so, and we're gonna have like memory is equal to memory inits, and this is gonna be so, like so, like so, like so. Anyway, Rust shenanigans, nobody cares. Mismatched type. Forgot how you declare an array, I guess. No, cargo check. Expected U size, found U16. Oh yeah, that's fine. That's fine. As use size, Okay. You can use a stack-based architecture. Is a stack-based like fourth? Thought I heard of that, but I don't know. I don't want to go too complicated, you know. I have this architecture, little computer tree. It's an educational thing. I don't want to dive. I guess fourth is well, that's in French, but oh well. Maybe I should put my thing back in English. Stack manage the function calls and execution state. Just tell me if I'm right that it's fourth, and maybe I'll do it another time. But otherwise, if you give me an example of a stack-based language, maybe I can actually look into it and see if it seems fun. But I think isn't like brainfuck kind of a stack-based language? Well, brainfuck doesn't have functions, but you know what I mean. Like you manipulate the stack to kind of make logic. Anyway. Register. A register is a slot for storing a single value on the CPU. Registers are like the workbench on the CPU of the CPU for the JVM is stack-based even if Java is not. Huh. Yeah, maybe I have no clue what stack-based means then. Stack manages function calls and execution state. Yeah, but that's every programming language ever, no? Like C is stack-based, no? Because when you call a function, it pushes it onto the stack. And the execution state is like which parameters are on the stack. So I would think C is stack-based as well. But apparently not all programming languages are stack-based, which surprises me because, yeah, I don't know, seems like a bit of a fundamental context. No, by stack-based, it basically means no register. Oh, okay, yeah. Yeah, it's true that C pushes like some arguments via registers. Yeah, I don't know. Huh. So it means that instructions are like add, and then it just pop to, yeah, oh, okay, yeah. Yeah, I've done that in the past. That seems, yeah, I think it's fourth is like that as well. Yeah, okay, this, yep, fourth is stack-based. Okay, I see. Yeah. And brainfuck is kind of like a bit like that, if I remember. Maybe not. No, never mind. But fourth is, and I've made like a toy programming language like so as well in the past, I think. But yeah, that sounds fun as well. I think I should just read up about fourth. Maybe that could be fun. I'm sure it is a bit more complex than what I have in mind. Or like it's possible to make more complex stuff with this. Okay, for the CPU to work with a piece of data, it has to be in one of the registers. However, since there are just a few registers, only a minimal amount of data can be loaded at a given time. Yes, that's good. The LC3 has a total of 10 registers, each of which is 16-bit. Most of them are general purpose, but a few have designated roles. 8 general purpose registers, 1 program counter, 1 condition flag register. The general purpose registers can be used to perform any program calculations, the program counter. Okay, so there is like one that gives the current address. The condition flag tells us information about the previous calculation. Okay, it's like overflows or things like that. Like it's used for condition, maybe like checking, like comparing, and comparing to a value before jumping to another address, stuff like that. So it has a bunch of registers. Sure, let's copy paste that. Let's make an enum register. Guess I can just remove this. Yeah. No, maybe I will rename it after, but that sounds good for now. Okay. And then, just like the memory, we will store the registers in an array. I don't really want to do that. I guess it's fine. Can I, wait, first, enum as integers. I think there is a way to, yeah, to just assign values to it. And then, yeah, it's like in C. Oh, I definitely do not want to do that. Hell no. That looks crazy. That's, well, I guess if he's gonna use like an array and this, it's kind of just like you have a big struct. So maybe I should just use a struct, you know, like, sure, registers can be structs. And each of those will be a U16, like so. There, and there, counts. And each of those is gonna have so, and all of that can be lowercase. Okay. Yeah, I think that's okay, but maybe I will need to loop over them later and I will regret this decision. But for now, it's okay. Okay, an array of registers, instruction set. An instruction is a command which tells the CPU to do some fundamental task, such as add two numbers. Yes. Instructions have both an opcode, which indicates the kind of task to perform, and a set of parameters which provide inputs to the task being performed. Each opcode represents one task that the CPU knows how to do. There are just 16 opcodes in LC3. Yeah, that simplifies my life a tremendous amount. Everything the computer can calculate is some sequence of these simple instructions. Each instruction is 16-bit long, with the left 4 bits storing the opcode. Okay. Huh. We will discuss in detail what each instruction does later. For now, we will define the following opcodes. Make sure they stay in this order so that they are assigned the proper enum values. Okay. Let's Save that program counter, like so. Hop, code, like so. Sure. Let's remove the prefix. Right. Like so. Let's just quickly convert this to what I want. Okay. Right. A VM, holy cow. Yeah, it's like this, you know. It's like an educational VM. So yeah, don't get too hyped. It will it won't take like it's not a tremendous amount of work. It's just to explore a bit. Note the Intel x86 architecture has hundreds of instructions, while other, such as ARM and LC3, have very few. Small instruction sets are referred to as risks, while larger ones are called CISC. Larger instruction sets typically do not provide any fundamentally new possibilities, but they often make it more convenient to write assembly for. Yeah, that makes sense. A single instruction in six, cannot pronounce that, might take the place of a several risk. However, they tend to be more complex and expensive for engineers to design and manufacture. This and other trade-offs causes a design to come in and out of style. Yeah, I moved to Switzerland 2 weeks ago. Started a new job here. So yeah, it's my new temporary apartment. I'm gonna be living here for 4 months, and I'm gonna have to move again and find a more definitive place to live here. Condition flags, the aircon registers. Ah yeah, this one. Okay. The aircon register stores. Nice. Stores condition flags which provide information about the most recently executed calculation. Okay, that makes sense. This allows programs to check logical conditions such as if x is greater than 1, something, something. Okay. Each CPU has a variety of condition flags to signal various situations. Oh, okay, I see. So this is gonna signal like above, below, and 0. Like it's just gonna compare to ints and give a flag accordingly. Yeah, bit shift, that's fine. We are finished setting up the hardware components of our VM after adding standard includes. See reference. I don't know what the fuck that is. Oh, okay, it's just like, yeah, what he wants. Okay, sure, whatever, I don't care. I do not care. Let's just add this. Let's just add this flag, tomb flag, like so. This is not needed, this is not needed. Oops. So, I guess, 0. Yeah, sure, whatever. So I can't set them to integers. Okay. That's nice. I did not know you could do that in Rust. Okay, so I have a lot of unused stuff for now, but let's see how I can use it. Assembly example. Let's let's take a look at an LC3 assembly program to get an idea of Maybe I should zoom in even more. To get an idea of what the VM actually runs, you don't need to know how to program assembly to understand everything that's going on, just try to get a general idea. So, okay, this is the address in memory where the program will be. Okay. Oh, okay, that's just part of the comment. Then load something, load address. So in register 0, we're gonna load the address of this string. Then put. Wait, that's put is an instruction. So branch, add, load, store, jump, bitwise something, load register, store, unused. Okay, bitwise not, load indirect, jump. Where's the put? There is no put. I'm getting scammed. What the fuck is this? There is no halt either. I'm confused. Just like see the program starts, or is it like fake assembly, or just like in C the program starts at the top and executes one statement at a time. However, unlike C, there are no nested scopes or control structures such as if or while, just a flat list of statements. This makes it much easier to execute. Notice that some of the statements have names which match the opcodes we defined earlier. Yeah, some of those. Previously, we learned that every instruction was 16 bits, but each line looks like it's a different number of characters. How is this inconsistency possible? This is because the code we are reading is written in assembly, which is a human readable and writable form, encoded in plain text. Yeah, no shit, Sherlock. Okay, fine. Thank you. Thank you. Okay, no, this is. I mean, it's fine, but it just assumes that you're, I guess, a more beginner. So yes, the text gets converted into some bytes. I mean, okay, I'm being a bit of a smartass. I guess I will get karma in a few minutes. Although a compiler is an assembler, sure, difference between a compiler and an assembler. The commands origin string z look like instructions, but they aren't. They are assembler directives which generate a piece of code or data like macros. For example, the string z inserts a string of characters in the program binary at the location it is written. Okay, loops and conditions are with a go-to like thing, so it's the br something. Why is it brn? Looks. Do you work as a software engineer? Yes, I currently work as an embedded software engineer. Note learning, and previously I was still a software engineer, but a bit more in computer vision or data science, or also a bit of DevOps, I guess. So learning to write assembly is not necessary for this tutorial. If you're interested, you can write and assemble your own LC3 programs using the LC3 tools. Okay, sure. Please, can we get to coding? Once again, the previous examples are just to give you an idea of what the VM does. To write a VM, you don't need to be fluent in assembly. Yes, okay. Proper display, physical. Okay, sure. Alan Turing code, of course. Procedure. Finally, how many years of experience do you have? I started working at 21, I think. Late 21. So I'm late 24 now. So 3 years, I guess. But I didn't have a job for 4 months, so maybe more like 2 years and a half. Eh, yeah, something like that. And yeah, before that, I studied for 2 years at a school before, and before that, I was just learning computers on my own. Here is a procedure you need to write. Load, load one instruction from memory at the address of the PC register. Increment the PC register. Look at the opcode to determine which type of instruction it should perform. Perform the instruction using the parameters of the instruction. Go back to step 1. Okay, that sounds simple enough. You never went to uni? No, I went to school 19. So I don't know if you know school 42. I don't know. Okay, the website doesn't seem up. Oh, never mind, it's there. So it's like, yeah, kind of like, I don't know if you can see in the pictures. But basically it's like, sorry, there is a fly, that's why I'm doing weird hand thing. But yeah, basically there is a room full of computers. They give you exercises and you solve them with the other people. So no, I never went to uni. I didn't finish high school. So yeah, you could say I'm a loser. I'm a loser dropout. See? Let's go. You may be wondering if the loop keeps incrementing the PC, the program counter. What is that Vim LSP you are using? Well, for Rust, it's called Rust Analyzer. No, I believe it's vice versa. You are smart. Yes. Well, I believe I'm all right. The more I work, the more I see a lot of smart people, and used to be a bit of a like I don't know. I used to think I was a bit too smart when I was programming alone because you have no frame of reference. You're like understanding some decently complex concepts, and you're like, oh, I'm so smart, and yeah, then you actually go work in real life and you realize, yeah, there is a lot of stuff to know. But yeah, you may be wondering if the loop keeps incrementing the program counter and we don't have a if or while, won't it quickly run out of instruction? No, as we mentioned before, some go to, okay, so there is a, yeah. Yeah, I'm in that state now. Oh, you think you're smart, huh? You think you start working with competent people. That's the key. Because of course, if you work with incompetent people, you're just gonna think you're even smarter than you are. So yeah. So there is a main. Since exactly one condition flag should be set at any given time, we set the Z flag. Okay, sure. So I need to have, I guess, memory is gonna be mutable. Let's mute registers is gonna be equal to registers, like so. Let's make, I guess we're gonna implement default for that. Can I derive default? That would be nice. I don't want to make everything equal to 0. Okay, we can. We can. That's good. But so David, are you like coding on your own, or oh? I started a year ago in my country. Programming is like a new hype. I'm from Georgia, by the way. Oh, okay. So everyone is hyped about web dev. Yeah, but I mean, I guess it depends on the country. If you just got the web dev hype, it makes sense. And well, there has been a hype for web devs, I feel like for 15 years now, but anyway. Bonjour Charles. Salut. Salut. But I'm not interested in it, so I'm just doing C. Yeah, that makes sense. I would say It depends on your situation. If you're just like still a student, just learning what you want to learn is nice. Otherwise, if you're like in a situation where you actually need to make money, it's better to just swallow the hard to difficult to the maybe just do it. Like I wanted to say like swallow the hard pill of learning JavaScript or stuff you don't particularly like, but to get a quick job. Anyhow. So I have my registers, but I don't know what career path to choose. Well, for C, there is only embedded, basically. Well, unless you're like extremely smart, but I would say for, I don't know, a regular person starting out, yeah, if you're just doing C and you want to do C for your career, I would say embedded is the way to go. But yeah, I don't think it's the easiest field to get into, but yeah, maybe I'm wrong. I just got my first embedded job and it was harder to get into than I thought. So yeah, I think data science or web dev is much easier to get a job. But yeah, anyway, I guess it all depends if you're actually thinking about your career or just learning, as I said. So the count register will be 0 by default. Yep, you're right. Yes. Oh no, it won't be 0. It needs to be initialized to this. So, well, actually, I guess. But I think it's more rewarding. Yeah, of course. But about salary. I don't know. Huh? I don't know if the salaries are much greater. Well, it depends what you call web dev. If you're doing like WordPress stuff, of course, I guess the salary will be low, or I assume it will. I hope. Who knows? Maybe if you're doing advanced WordPress, maybe not. But I think I would assume the salaries in embedded are not much higher, huh, to be fair. To be honest. So maybe I do need to implement this for registers. fn default, and so it will be registers. I wonder if I can do like so cond would start with well, it doesn't matter to put it above, but I don't know, it feels bad, so I'm gonna put it above. Cond is gonna be cond a flag. I guess I can just name it cond, that's fine, and then it's gonna be this, and the rest is gonna be defaults, like so, and then this can go away, and this, oh wait, no, the flag can go away as well. So let's check again. Expected U16 found count. Oh, right. I guess this can be a count for now. Is that good? Yeah, just a lot of unused stuff. Cannot return without recursing. Oh, fuck. Maybe I'll do web and just work on C projects aside, or the YouTube would be nice. By the way, I'm not gonna distract you anymore. Yeah, I don't care, you can distract me all you want, that's fine. Otherwise I wouldn't be streaming. If I wouldn't want to be distracted, it's nice. Function cannot return without recursing. So you mean that if I run this, it will be recursive? Oh, fuck. It's annoying. I don't want to make the default for all of those. Maybe I can do like, okay, fine. Let mute registers is equal to default Fuck, I can't do that either, because it will recurse. Horror. Fuck it, I'm not dealing with this Rust shenanigans for now. Let's just make default here, and let's say registers cond is equal to cond. This. Anyhow. I noticed you attended 42. What do you think of are the advantages of 42 compared to traditional school, engineering schools like NCMAC? I don't know what NCMAC is. Is this like a joke? Are you gonna say NCMAC balls or something? I got tricked. Please, I don't want to get tricked. What is NCMAC? Oh no, it's Grenoble. Okay, it's a real thing. Never mind. Yeah, I don't know. I don't know about this one. I think School 42 is really nice. Although they have gotten quite a bit woke lately, but yeah, anyway. If you focus on the programming, it's great. Not the skibidi thing. I don't understand the thing about the skibidi. It just hurts my brain. I feel so old saying that. But yeah, 42 is great. You get to meet a lot of passionate students. And yeah, just chat about a lot of fun things. I think if you like computers, it's the way to go. And it also seems like universities, at least in Belgium, from what I gathered, are really, really bad at teaching programming. Like you still write on papers or stuff like that, or you learn irrelevant programming languages. I mean, it's probably not bad. Like you got a master's degree from a university, you probably know a lot, but I think you could have learned faster in a better environment. At least I think that's what I saw in the real world. I think it only applies to computer science, probably though. Huh? Like if you want to do electrical engineering or mathematics or physics, uni is probably much better than learning on your own, I would guess. So we set the condition flag to be 0. Set the PC to starting at position this. Okay, sure. Why the fuck not? So registers. I think it's the register PC is equal to this. Enum PC start is equal to what the fuck? Okay, sure. I don't know why he creates an enum. Like, what is this? What is this, my dude? Why are you creating a random enum? That sounds sus. Anyway, so it's running in a while loop while running. Memread and memread is gonna be implemented later. Sure. Let's implement that. So let's just do loop because why the fuck not? Let's remove the hello world. Then let's instruction is equal to be mem. Right, it's gonna be a U16 and to do like so. Okay, and then let up is equal to be instruction shifted by 12 bits. So, okay, that's a bit strange, but I guess it's just convention. Then, then we have the opcode, which is there. So I do need this to be 0, and then we match on the up. No, first we need to convert this to can we do, so this is an opcode. Can I do like BR, for example, something, and then ignore the rest? Does the conversion from enum to U16 was this easy? No, it was not. Let's see. Trade default is not implemented for cond. Oh, yes, sure, that's fine. Imp default for cond. Ah, I can do it here. Yeah, that's so easy. Default is gonna be cond 0, like so. And so later I can actually remove this. So expected opcode found U16. Okay, can I first convert U16 into enum? First convert from any unsigned into enum. Do you use NeoVim at work too, or do you prefer IDs? I hate IDs. I use NeoVim everywhere. I don't know. I don't hate them. I just find them inconvenient. They're just so annoying. Like tons of pop-up everywhere, and I don't know. It's too much distraction. They are convenient for some things at least. Like if you get started, yeah, bloated. I would say as a student, you don't really need them. Like a lot of the stuff is too advanced. Like basic completion is good enough if you're a student. They are good for like good language server capabilities. Like if you really have a big code base and you need to generate a lot of code or jump to a lot of definitions, it's nice. But I don't know. It's like yeah. I guess it's easy to do complex stuff, but yeah, it does a lot of stuff that I don't want it to do as well, so that's why it's a bit annoying. Yeah, there is the repr thing. Yes, let's see. I wonder if this works. Repr U16. Does this work? Hmm. Do I really have to use transmute? That sounds kind of cringe. I just use Vim with a simple autocomplete plugin. I'm fairly satisfied with it. Is NeoVim really that much better? Not really. If you like simplicity, I think Vim is fine. LSP is much better on NeoVim. Well, I never tried to do it on Vim, but yeah, I don't know. And also, I just like the thing that the fact that NeoVim is rewriting most of the stuff in Lua, which is well better than VimScript, but it's not very hard to do better than VimScript. Like this is the most horrible language ever. Native LSP is kind of nice. Yep, please. I think if you really want native LSP that is even better, I think you have the hyper text editor. Like, is it hyper? No, it's not hyper. What the fuck am I doing? Saying it's like Helix editor. This, which is based on Vim, I think, but it has like, I think it has built-in LSP. Yeah, language server support, tree-seater integration is basically, I don't know, if you don't want to fight too much the NeoVim config, I think this is probably good. I should try it at some point. How complicated is it to cast a freaking enum to... no, I do not want to do a freaking match, please. I beg you. I beg you, please give me a shorter way. Derive from primitive. Derive from primitive. Ok. Oh là là, oh, fuck it. Fuck it. How is it not possible to do this? So cringe. So cringe. Come on, there has to be a way to integer. How do I convert an enum reference to a number? Is correct, but you have to implement copy because otherwise you would have to leave behind an invalid reference. Okay, so can I do this and then derive clone copy? Still not as code. What does it say? Unreachable statement, sure. An as expression can be only be used to convert between primitive types. Oh, fuck. So that sucks. That sucks. How do you do it the other way around? Integer to enum. I don't want to match my dude. I want to. Fuck. Why is this so hard? Okay, fine. I'll just. You can derive from properties using. I'll just use this. Let's see. Apparently I need a crate for this. No, wait, it's in the standard library. What the fuck? Rust programming language. No, I don't want the book. Doc. I want the documentation std. There we go. Primitive. Std primitive. What? Okay, whatever. Cargo, add, no. Okay, good enough. Can I use num from primitive, like so, derive from primitive. Cannot find derive macro from primitive in this scope. How? First num from primitive. So can't I derive this? That freaking sucks. That freaking sucks. Oh, num derive. Okay, sure. There is another crate. Guys, I have an idea. Let's create 3000 crate. So there is num and num derive because, of course, every time you have metaprogramming in Rust, it needs to be in a separate package. Because that makes sense. Okay. Derive. Can't find crate. Num traits. What the fuck is going on? Okay, do I need cargo add? This is a meme at this point. Wait, traits. Okay. Okay, fine. I cannot use the add. What is this text editor? I was away. Yeah, it's just a vim replacement, a vim rewrite. Yeah, sure. I do into. Strain from U16. Okay, how do you convert then? Okay, that's great. That's great, that's great. So it derives this. And then I can do from, okay. Okay, I can do opcode from U16. Oh, so much effort. It's not finished. God damn it. Isn't there U16 there? Yeah, there is. What the fuck are you saying? What are you saying? Oh, it's optional, I guess. Variant of association not found in opcode. What? So there is I16, but there is no U16. But I see here that there is U16. What kind of shenanigans is this? I think I stopped caring, so I'm gonna use I64. What the fuck is going on? So I16 was correct. What the fuck? It tells me to use. Wait. It tells me to use U16 in the error message. So strange. Oh, what the fuck? No. It tells me to use U16. And then it tells me it's not there. And when I use this, it tells me to use I16. What the fuck? So use null traits from primitive, I guess. Fuck, finally. Okay, that was. Thank you, Rust. Thank you. Thank you. That was nice. That was pleasant. Fuck me. Okay. Okay, did it actually do what I expected to do? Like, go away. Print ln. Sure, let's print like this. And let's do this. And so if this is 0, what? Sure. You can add debug here. That's fine. All right. So 0 is BR. That's fine. What is trap? Wait, no. So trap. I don't know, but like, how about 5? 5 is end. That makes sense. What if I put 50? None. Incredible. And it returns a sum. Incredible. nvim.files, please. Yeah, you can just go on my GitHub and look for .files, but should put those somewhere because, I don't know, people keep asking for them 1,000 times. I don't know. Maybe I need a YouTube bot that detects if people say .files and automatically answers the comments. Can you do that on YouTube? Like in the YouTube chat, maybe. Like for live streams, but can you do that on videos as well? And I would make that bot answer directly the .files questions but also the French accent questions. It's like, oh, you have a French accent. Are you French? Yes, I'm French. Thank you for reminding me. So I would do those two questions. God damn, I'm a shit little YouTuber and I already get annoyed by repetitive stuff. Must be a nightmare to be like have a million subscribers. Like you have to hire a whole team to answer like the most regular questions. It's crazy. Anyway, it works now. It works now. Up. Let's just name it up. That will be simpler. So you are French. Crazy, right? No, I'm not French. You can guess my my country of origin if you want. But I'm not French. Try rapping. Oh, okay. For now, we can do unwrap. I think just here maybe unwrap. Okay. Finally. Swiss then. No, not Swiss. I just moved to Switzerland. Belgian, yes, I am Belgian. It only took you 3 times. But yeah, as a Georgian, I'm surprised you know about Belgium. It's, well, I thought nobody knew about that country besides the people living in neighboring countries. Okay, so it just has a bunch of things. So what I can do is can do an expect here, bad up, bad up. Then I can do just basically all of this. Up. I'm crazy, you know Georgia. Is Georgia crazy? I don't know. The only thing I know about Georgia is that initially Stalin was from there. But besides that, I think I watched like one vlog or two about Bold and Bankrupt going to Georgia, maybe. But besides that, I'm not sure. Hop. Alright. What am I doing wrong? Oh, yeah, this. Okay, can you compile now? Well, it doesn't work, but can you compile? Yes. Yes, that is correct. However, Georgia is skibidi. What the fuck is it? What the fuck does that mean? Please use real world words. What is Georgia is skibidi? What the fuck does that mean? We know all of the country. We know all of the geography just from thinking about immigration to win them. Oh. Wait, does Georgia does the immigration or do they just don't like immigration and so they look at other country like you're dumb to have immigration? I'm so confused. I am a bit confused. Okay. What else do we do? Does it do? That's it. Okay. Is there anything special? So, what does res do? Yeah, res reserved unused. Okay, so res and op rti do nothing, so we can put those at the bottom. Okay, and the rest will be implemented later. So if I jump to this, oh, it shows me. Okay, that's nice. No, I mean, we are poor, so everyone is trying to migrate to EU. It's supposed to be fine. I'm. Oh yeah, yeah, funny. Yeah, yeah, yeah. No, it's okay. It's okay. It's okay. Well, I'm a migrant myself now, I guess, since I'm out of Belgium. So yeah. But I mean, if you're a web dev and you can work remotely, and you're like getting like, let's say, I don't know, Belgium salaries, but you live in Georgia where the cost of living is cheaper, and you actually know the country, you're like live there all your life and you're comfortable there. Uh, you can be like basically the king of the world, kind of, just by making websites. That's kind of nice. I thought about that at some point, like I should get a remote job and just go live in I don't know, Indonesia or Moldavia or something, and just pay like €100 of rent and make a ton of money. But I don't know. I thought that would be like for me to like actually move there while I don't know anybody. It would actually make me a little sad. But if I just lived there and I had friends and family there, I think it would be okay. Uh, While we are at the main loop, let's handle command line input to make our program usable. We expect one or more paths to our VM images and present a usage string if none are given. So, okay. Read image. Sure. Yeah, I'm not sure what to do with this, but sure. To do read path from args. Okay. Yeah, but the thing is that we have low salaries and high prices on rent and groceries. Oh, yeah, that sucks. But I guess if you get a remote job, you still. I'm assuming that like the price of rent and groceries is still lower than in Belgium, France, or stuff like that. I would assume. Uh, or America, or any of the location where you could remote. But yeah. No, really? Like for a single person, it's still higher. What? Makes no sense. How is like let's say a flat for one person, like 2 rooms, uh, like a little kitchen, a little desk, like what I don't know, a single man would use worth like per month in Georgia. In Belgium, it's around between I don't know, 550 and 700, I would say, per month, without counting like the water, electricity, and so on. Implementing instructions. Your task is to fill each opcode case with a correct implementation. This is easier than it sounds. A detailed specification for each instruction is included in the project documents. The specification for each translates pretty easily to several lines of code. I will demonstrate how to implement 2 of them here. The code for the rest can be found in the next section. Oh, he made like oh, that's nice. Okay. Oh, okay, so the opcode is the first 4 bits. And then there is the rest of it. That's nice. Really? $1,000 minimum. How are you alive, my dude? Oh, wait, no, that's crazy. Oh, sorry for that. Sorry for your ears. if you will rent lower than 1K, it's just a shithole. You will live with biases. Hell no. Is it like a government mismanagement thing where they're just corrupted? Or is it just that the economy is really bad? Or what is the cause of it, if you would have to say? So government is just mismanaging things. Corruption. Yeah. Okay. That's sad. That is sad. But yeah, a lot of the I don't know what this area of the world is called, like Georgia, and I don't. I know you have like 4 countries stacked, where Georgia is like the one that is named like a country, and the other are just end with stan. So Uzbekistan, Kyrgyzstan, stuff like that. I think is in this area, and from what I've heard, yeah, there is a lot of government corruption in those areas, in those countries. But anyway, I'm reading this on the internet, so I don't know shit. Anyhow, so let's see how he implements the add instruction. The add instruction takes 2 numbers, adds them together, and stores the result in a register. Its specification is found on page 500. There is 500 pages to this. Okay. Each add instruction looks like the following. Okay. So that's the opcode, I'm assuming. So 0001. And yeah, this is 1 since it's the second one. Okay, that makes sense. We are near Turkey and Russia. Russia, I know. I just have to pull a map. Was I this wrong? Is my geography this shitty? Let's not dox myself, please. Wait, let me pull that in another tab before I dox my location. I'm not a very good YouTuber. Well, Google Maps is loading, I guess. Okay. Well, okay, this is too abstract for you to know. So, Georgia. Yeah, no, I was right. There is Azerbaijan. Oh, never mind. I wasn't right at all. Fuck. Okay, never mind. Well, it's all countries that are part of the old USSR bloc. So yeah, just my geography is way off, I guess. Okay, I see. Boom. That instruction takes 2 numbers, adds them together, and stores the result. Yes. The encoding shows 2 rows because there are 2 different modes for these instructions. Yeah, according to the argument, the modes of an instruction can change. There's that in x86 as well, I think. For this instruction, before I explain modes, let's try to find the similarities between them. In both rows, we can see that we start with 4 bits, 0001. This is the opcode, yeah, that makes sense. The next 3 bits are marked DR. This stands for destination registers. The register, there is only 3 of them. The destination register is where the added sum will be stored. The next 3 bits are SR1. This is the register containing the first number to add. Oh, okay, I see. So destination and operand 1, operand 2, and then a bunch of padding in between. But I live hardcore life and chose embedded shit in this situation. Well, who knows, I don't know. I would say unless you're really, really in the shits, it's nice to follow. Let's say, I mean, I don't know. It's not really a dream. It's achievable, definitely. So yeah, it's a nice thing to pursue. I think you should do it. Uh, and I think eventually you get paid higher, probably. I think at the beginning, probably not that much. But I think people that are interested in C are rarer than the one interested in JavaScript. So by definition, you will be more valuable because you will be rarer, I think. But do you think that it's hard to find a job in the US than the EU? I don't know. I've applied to like accidentally. I've applied to one job in the US. Didn't seem that bad. But yeah, I don't know. I just know the EU much more, and so that's why I applied more in jobs in the EU. Man, I love your advanced C series. Thank you, thank you. I am regretting naming that advanced C because it's not really advanced anymore. Like I'm just talking about, I guess, intermediate stuff. Sometimes advanced. So, but yeah, at the time I had like 3 viewers. So can you really blame me for misnaming a playlist? But anyway, I'm glad you liked it. But yeah, I don't know. I think like a Georgian person would have more in common with the EU than America. But yeah, I mean, I guess it's both very far. Uh, yeah, I don't know. I would say just try. And you know, when you search for a job, you just apply to 200 things in the beginning, and there is like maybe 10 that stick and one where you go past the interview. So yeah, you just have to apply to a lot of things and have a decent enough resume. Try to put yourself out there on GitHub or YouTube, as you said. And yeah, hopefully, I mean, some people only look at the university thing, but others actually care about what you know. Do you have any CV recommendations? No, my CV is garbage. I've made it using Pandog to convert it from Markdown to PDF. So I'm terrible with or how can you find internship without experience? Well, for me, my first internship was just through the school. Like there was a guy that worked at a company, and then I just got an internship there because it was I knew the guy. That's it. So yeah, knowing people helps a lot, especially if you hate if you're not familiar with looking for a job, as was I in the past. Mark 30 stands for Destination Register. SR1 register containing the first number to add. So we know where we want to store the result, and we know the first number to add. The last bit of information we need is the second number. I think I would like a bit field for this, because how does he do it? Yeah, he does like row operations, which is kind of annoying. Yeah, he does this kind of stuff. I don't know, man. First, bit flags. Let's see. Create bit flags. You can do this. No, not bit flags. I'm fuck. Bit fields. Yeah, that's what I meant. Let's see. Bit fields struct. What's up? What's up? I'm currently writing a little VM. It's like a toy VM. Up. Or at least I'm trying. Why did you stop using Sorex? Because I moved to Switzerland and currently in a temporary apartment where I don't have access to the router, and Sorex used to run on one of my servers, which is just on the, like, there. I have just the pile of servers that I have, and they're just not connected at the moment, so I don't have like Jellyfin, Sorex, and other services that I used to have. Don't have my VPN and my DNS either. But oh well, it's only for 4 months, so I'm using Google. And also I wanted to try back anyway to use Google's, because some of the time Sorex, the search results are a bit shitty, and same for DuckDuckGo. So yeah, I wanted to try out Google again to see if the spying is worth it. So yeah, that's it. Yes. So you do that. Yes. Boolean large, just one bit large. Don't want this though. Yeah, maybe this is more complicated than it needs to be. Yeah, but it transfers things from Google and other search engines, right? But yeah, but it's not quite that simple. Because yeah, in an ideal world, that's what it would do, but like the search engines can detect that they're being scraped basically by SERPs, and so they give you, I think, worse search results so that you stop doing that and use their website directly. So yeah, it's just that SERPs has a hard time, I guess, pretending to be a human. Yeah, that sounds a bit overkill, maybe. Never mind. Yeah, okay. Yeah, never mind. Let's do it like the guy does it. Okay. So we know where we want to store the result, and we know the first number to add. The last bit of information we need is the second number to add. At this point, the two rows start to look different. Notice that on the top row, okay, the padding is not really padding. It's more like, okay, this is padding, like the 4 and 3. But the 5 is like a flag, so if it's 0, we are directly loading the value. If it's 5, it's, I would guess, an address. The fifth bit is 0, and in the second row is 1. This indicates whether it is an immediate mode or register mode. Okay, never mind, this is a register. In register mode, the second number is stored in a register, just like the first. Okay, it is marked SR2 and is contained in bits. Oh, okay, so the first one, this is SR2 is a register as well, and M5 is immediate, so it's just an integer. That sucks a bit because it's like, you know, only a 5-bit integer, so yeah, I guess that works. I guess it works. In assembly, this would be written as add R2, R0, so we add R0 and R1 into R2. Okay. Immediate mode is a convenience which reduces the length of a typical program. Instead of adding two values stored in separate registers, the second value is embedded in the instruction itself, marked as M5 in the diagram. This removes the need to write instructions to load the value from memory. Okay, that makes sense. If you're a constant, for example. The trade-off is that the instruction only has room for a small number. Okay, so only from 0 to 32. To be exact, this making immediate mode is primarily useful for incrementing and decrementing. In assembly, it could be written as Ah, okay, yeah, that makes sense. What was your first big project in C? I don't know. I think it was in school. GitHub.com. Oops, not that. It's a great project to learn C, by the way. It's stuff they made us do in school. It's basically you rewrite the standard library or anything you can rewrite. You know, if you're a beginner, you can't really rewrite malloc. That's a bit too complex. I mean, you can try, of course, that's great. But if you're a beginner, here you just basically like maybe tag row. Yeah, that's good. So yeah, they just make you rewrite. I don't know if you can read. I'm gonna do it. Yeah, it's great. If you're and in addition, so I'll give you the link. But also there is for each of the exercise they gave us in school, they gave us a subject PDF, and so that's basically yeah, you can read that. It's in English, and they explain what you're supposed to do. And oops, if you load more pages, they just describe all of those you need to rewrite, basically. And yeah, of course, you could look at my solution, but that would be too easy. And so, yeah. And what you do is basically you rewrite all of those, and then you have your own function that you prefix with something, and you just compare it to the original function to see if it has the exact same behavior. So yeah, that's it. There's some extra ones that are not present in the standard library, for example, strtrim. But some of those, a lot of them, like strncopy, strncompare, atoy. Atoy is a great one to rewrite at the very top. ASCII to integer. There is the opposite E to A, so integer to ASCII. Anyway, a bunch of nice things. And if you want to go a step further, you can do libft test. Type into, since it's a school, like there is plenty of people that do automatic tester for you. So I guess that's not the one that I use, but you can see that. Okay, no, this one seems a bit weird. Yeah, this is the one I used. So yeah, you have an output like this after. You just run this script and it will test all your functions that you wrote with unit tests made for you, basically. But that's pushing it a bit, like if you're not doing the school itself. That's a bit overkill, I guess, for something. But anyway, and you can even benchmark your functions against the libft. And that's how I discovered like SIMD optimization and like copying like 16 bytes at a time instead of like 1 byte at a time, for example. So anyway, you can also look at aligning the address when doing a copy or a set, which is a nice optimization. Anyhow, back to the thing. Immediate mode is a convenience which reduces. Of course, the big fun part of this project is just that you're doing it with the other student. Like, I guess it's nice as well. I was doing it alone at some point, but if you have other people to talk to with, how did you implement this, or you should change that maybe, and stuff like that. That's really nice. Anyhow, immediate mode is a convenience, mainly for incrementing. That makes sense. Here is a summary from the specification. If bit 5 is 0, the second source operand is obtained from SR2. If it's 1, the second source operand is obtained by sign extending the IM5 field to 16 bits. Oh, okay, sure, doesn't matter. That sounds just like the behavior we discussed, but what is sign extending? Okay, never mind, it's not a sign extending the bit into 16 bits. Yeah, indeed. What the fuck is this? The immediate mode value has only 5 bits, but it needs to be added to a 16-bit number. To do the addition, those 5 bits need to be extended to 16 to match the other number. Okay, for positive number, we can simply fill it with zeros. Yeah, that makes sense. For the additional bits. For negative numbers, this causes a problem. For example, -1 in 5 bits is 1. Yeah, 5 times 1. Yeah. If we just extended it with zeros, this is... Oh, which is equal to 31. Oh, sign extension will just move the sign bit to the end. Corrects this problem by filling zeros for positive numbers and ones for negative numbers, so that original values are preserved. Okay. Have you written any ASM when you started coding? Not when I started coding, but thank you for asking this question. I have a school project to recommend to you again. GitHub. So there is lib ASM. And so it's similar to the project I just gave you, except you do it in assembly. So here is, for example, a string copy in assembly written by me. Or you have, I don't know, some linked list things, which I created as well. So there you go, if you want to torture yourself. You can do libasm, and again, there is a subject.pdf that explains what you're supposed to do. I feel like it's my birthday, yeah. You're welcome. Yeah, the projects in this school are really nice. So yeah, I think you can find them online if you just type 42 school 42 subjects. You will have like a list of 100 PDFs or something, and all of them are like good projects like this. At least they're like good ideas to learn computer science, you know. It's made for students. Let's see. So, how do I implement this? Sign extend. So, if x bit count -1. Whoa. Oh, that I do not understand. I don't want to copy paste this. So we want to sign extend x. So x is like 5 bits into 16. And bit count, well, I'm assuming in this case it's 5. So we left shift it by 4. So we get rid of the data and only keep the sign. Then we do this to only keep the sign bit. Okay, that makes sense. Then we OR the original value with this bit count. Okay, so this like basically means if it is signed as a 5-bit integer, we OR it with so this is full ones. But we shift them right there. So basically it will have the number and then only ones. That sounds a bit strange. Is it like just like 2's complement? Okay, note if you are interested in exactly how negative numbers can be represented in binary, you can read about 2's complement. However, this is not essential. You can just copy the code above and use it whenever the specification says to sign extend the number. Okay. Okay, but I think I understand most of it. I haven't looked up at 2's complement for a very long time, but I know it makes sense because smart people said it did. So this is U16. This is just well, it can be a U16 as well, I don't mind. Can I comment this a bit more? Like, only keep the part before the data. Only keep the sign bits. This is a weird way to do this, but I think it's okay. Can't I do this? Don't need to do this. And this is like this is like tools complements. Yeah, need to look into this. But why doesn't it compile? Why doesn't it compile? Expected bool found U16. Okay, fine. It's like if all of this is equal to 1. First convert U16 to bool. Will it work? Convert the single byte to bool. Can I just do as? Try from. Yeah, whatever. I can just do equal 1. That's fine. And this can be nuked. I don't care. Okay. Okay. Sign extend. There is one last sentence in the specification. The condition codes are set based on whenever the result is negative, 0, or positive. Earlier we defined the condition flag enum, and now it's time to use them. Anytime a value is written to a register, we need to update the flags to indicate its sign. We will write a function so that this can be used. Update flags, register R is equal to 0. Oh, okay. A 1 in the leftmost bit indicates negative, yeah. Okay, that makes sense. So can I do registers? Okay, that's registers. Can I put this above? Can I do update flags? Rcond. Okay, and so we just need. Oh fuck, this is annoying. This is annoying. So it will give me just being a register. Oh, can I just say type register is equal to U16? Or even not care about that and just say that R is or 16, like so, and let's see, mutable reference to self. If r is, well, it's more like, I don't know, value. Let's just call it x for simplicity's sake. If it's equal to 0, I'm writing like C in Rust, that's not great. Else if x left shifted this is equal to 1, we know it's negative, and else it is positive. So this means that self cond is equal to cond 0. This is negative. This, oops. This is positive, like so. Is there a nice way to match this? Plus match on bit pattern. Bit level pattern matching. Yeah, that would be nice. Yeah, that's just an if. Yeah, I'm not doing that. That's crazy. Two bulls and slice. Okay, this is a bit of an over-engineer. Okay, never mind. Let's just keep the if else. That's fine by me. Okay, so this is basically what I have. Now we are ready to write the code for the add case. Okay. So destination register, first operand, whether we are in immediate mode. Im flag, otherwise. Otherwise we do like this. Oh, okay, I see. So we need a function. I'm gonna stop the LSP. Oh, can't stop it. Well, fn add, which takes an instruction, which is just a u16, and returns nothing. Let's say, and it takes registers. Register. It's gonna be a mutable reference to registers. Then we're gonna have R0 dr. Let's call it dr is equal to instruction shifted by 9 and with 0x7. Okay, I don't really like this though. When I do Python 0x7 2 bits. Okay, it's just 111, so it's just 3 ones. Like when matching bits like this, I prefer having like directly the bits. That makes more sense to me. Okay. Then we have as R1, which is the instruction shifted by 6. And then again, 3 like so. So both of those are registers, and we know 100%. Let's immediate. Yeah, I think that's how you spell it. Flag is equal to instruction left shifted by 5, and we end it with just 1. That makes sense, and we can just do that. This is equals to 1. We are in immediate mode. If immediate flag do something else, Okay. Sign extend this. So then we have the immediate value is equal to sign extend, and this is going to be the instruction. And again, he's doing like weird stuff, so that's just like 1, then 1, 2, 3, 4. This like 5 ones, and bit count is just 5. Okay, and then we say registers. Oh yeah, fuck. Okay, that's why we need an array of things. That sucks. That sucks. That sucks. Oh well. Let's do it later. Register, let's basically say dr is equal to registers sr1 plus immediate value, like so. And then later we will also need let sr2 is equal to instruction, and 0x7 is just 111, like so. And yeah, that's the same, but now we need registers sr2. Okay, that's it. And finally, we need to do registers update flags. And update flags is with registers dr, like so. Okay. Need to find a way to make this a bit cleaner. Yeah, I don't know. Maybe I should just have an array and an enum of registers as he does. That seems a lot simpler. Anyway, I think I'm gonna stop the stream and start on another day because I need to eat. I'm very hungry. And yeah, not used to streaming anymore, I guess. But anyway, that doesn't sound too bad, and so that's just how you implement add. I'm guessing the basic instructions are extremely similar to this, so could probably be generalized. Like you could pass, let's say, f will be a fn once that takes a u16, and then that returns a u16. Like so, and then you can just use f here, like so, to generalize a bit. I think that would be easier, so that you can implement subtraction, multiplication, and all that good stuff very easily. And so add an LDI stands for load indirect, and now he's like loading a value in memory. So I can see. So for example, this is the destination register, and that's the PC offset. Oh, okay, nice. RTI and res, they are unused. Bitwise not. Okay, okay, okay. Okay. And after that, you just run the thing, and that's it. Put trap code. Okay, so there is signaling as well. Okay, that's nice. Anyway, see you next time. Maybe this weekend I will stream a bit as well and finish this virtual machine stuff. We'll see. Anyway,